Yesterday, when we were talking about it, we talked about the constant rate of change. Remember, constant rate of change? Constant rate of change is when we're talking about constant change of y over the constant change of x. We call that CRC, but we also said that it's later going to be known as the slope in a problem. So we did a couple of examples showcasing constant rate of change in a table and how to identify constant rate of change from a graph. You're just identifying how your graph or your table changes for the y's over how it changes for the x. Now, one thing that I did want to make sure that you understand, especially with a problem like this one. Remember I told you guys yesterday that a lot of people looking, they go, oh, it goes -5 and then it goes -4, so that does not have a constant rate of change. In this situation, yes, that's true, but it's not always true in every situation. Sometimes if you have differences of change in one column and you also have differences of change for your x, then there is a possibility that it still has a constant rate of change because they might be proportional or equivalent changes to each other. So I want to show you an example of what I mean for that. So I know that I only gave you 3 examples up here, but what I want you guys to go ahead and do is in this space below here, just go ahead and put down that you're going to put table D. If you do not have your notes with you, instead of just sitting there, you should just take out a piece of paper and start writing. It's a suggestion to you. Then get out a separate sheet of paper and attach it to your notes. Okay? So here, I'm going to create the table. I've got 0, 2, 3, and 6 for my x's. For my y's, I'm going to go 2, 8, 11, and then 20. So again, I'm wanting to identify first my constant change of my y. So if I'm talking about the change that's occurring to the y, I'm going from 2 to 8. What kind of change is occurring? Don't just say 6. Plus 6. This change that's occurring here is a plus 6. Then I'm going from 8 to 11. That changes what? Plus 3. Then 11 to 20, that changes plus 9. So they aren't the same. Okay, they are very different, going 6, 3, 9. But I have to still check the change of x to see if I can create proportional change. So when I'm taking a look at the x values, I'm going from 0 to 2, which is a plus 2. From 2 to 3, that's a plus 1. And from 3 to 6, it's a plus 3. So again, those are very different as well. So what you need to do is you have to check each and every single change of y over change of x to see if they equate to the same value before you can decide whether or not it is a constant rate of change. So I would set it up as 6 over 2, 3 over the 1, and then the 9 over the 3. And I have to ask myself, are those the same? Are they equivalent or equal to each other? Oops, sorry, thank you. Thank you for catching that. Okay, are those equivalent ratios? Are they equal to each other? Do they all simplify to the same thing? Yeah, they do. So the fact that they are all equal to each other, then that means you do have a constant rate of change. But which one do I go with? Why? Because it's in simplest form. You want to go with the one that's in simplest form, 3 over 1. So yes, this would create a constant rate of change. That means that it is a linear function. Okay, our constant rate of change is going to be equal to 3 over 1. We don't have any context in which to put it at, so I can't say, oh, it's $3 per hour like I did here, or 3 minutes per volunteer like I did here, because I don't have any context to go with it. But if you did, you'd have to indicate 3 per 1 what, okay? And since it does have a constant rate of change, it means that it does make it linear. Remember, linear means that it's going to form a straight path. if I were to graph these points and connect them together, I would see a straight line that's going to exist. Okay, so I just want to make sure that you understand just because they are different values that it's changing by does not mean it's not going to have a constant rate of change. Sometimes it will and sometimes it won't. Okay, so for problem E, you're going to draw another one. Again, we're just going to do a quick table. It's really easy to identify if it's a linear relationship with a graph, right? That's a visual representation. You can easily see that it's a straight line. That's not the problem. It's the table that I think you guys need the most practice with, just because you are having to identify the constant rate of change first. With the table, if you can see that it's a straight line, you know it's linear, then you just identify what those change of y over change of x is visually. Okay, go ahead and try this one on your own. For your x values, you're going to have 17, 9, 4, and 1. For your y values, you're going to have 47, 23, 8, and negative 1. So I want you to identify whether this represents a linear relationship, and if it does, what was the constant rate of change. Okay, so is this going to be a linear relationship, yes or no? Is it linear or not? Okay, if it is linear, what's the rate of change? Huh? Which simplifies to what? 3. So our constant rate of change would be a 3. If we're taking a look here, that change of y, we're going from 47 to the 23. That means that we are decreasing, and we're decreasing in this sense by 24. From 23 to the 8, we're decreasing again, but this time by 15. And then from 8 to the negative 1, we're decreasing again, but this time by the rate of negative 9. Okay? For the change of the x, we happen to also be decreasing. So if both sides are decreasing, is that a positive or negative? If both sides are decreasing, will that create a positive or negative relationship? Positive. If both sides are decreasing, it creates a positive relationship. Remember, 2 negatives is a positive. If one side is decreasing while the other side is increasing, that creates a negative relationship. Okay? So here, from 17 to 9, that creates a negative 8 for the change. From 9 to 4, it's a change of negative 5. And from 4 to 1, it's a change of negative 3. If you were to go ahead and check each of these individually, you would have negative 24 over negative 8. Again, a negative over a negative will come out to a positive. You would have a negative 15 over a negative 5. And then you would have a negative 9 over a negative 3. Sorry, ignore it. Okay, so all of them, they listened to me. All of them would be equal to each other. They all happen to be able to simplify to the same value, which is 3 over 1, a positive 3 over a positive 1. So it does have a constant rate of change of 3, or 3 over 1. That does make it a linear relationship. Okay, and remember, again, I'm going to put emphasis on the fact that linear means that it is going to be a straight line when you graph it. The reason I want to put emphasis on it is because when we get into proportional relationships, all proportional relationships are linear, but not all linear relationships are proportional. It's kind of like that whole finger and thumb thing. So, you know, all thumbs are considered to be a finger, but not all fingers are considered to be a thumb. Do you guys understand that? Okay, so it's the same idea here. All of your proportional relationships are going to be linear, but not all of your linear relationships are going to be proportional. For example, right here, I can tell you right off the bat, this is not a proportional relationship. It's linear, but it's not proportional. This is also not a proportional relationship. Linear, but not proportional. This is not going to be a proportional relationship either. So all of these are linear because they do have a starting point other than what we call the origin. What do I mean by the origin? 0, 0. So if you notice, when x is 0, is y 0? No. When x was 0, y was 2. In order for it to be a proportional relationship, not only does it have to be linear, but it also has to start at the origin, or it has to have the point 0, 0 as its data point. So underline or identify this right here. When we talk about proportional linear relationships, they need to be a straight line and this is a really important feature, they must pass through the origin. And again, that origin is 0, 0. So if you're looking at a table of information, the table would be able to eventually have the point 0, 0 on it. If we're looking at a graph, we would see that it's going to cross through at some point on the origin, or it would be able to connect to the origin at some point. Okay, so if we are looking at example number 2, we're trying to determine if there is a proportional linear relationship occurring here. So that means that we have to first see if it's got a constant rate of change, and then we have to see if when we graph it, will it connect to the origin. Okay, so for here, we have speed and we have time. We have speed and we have time. Now remember, time we always write as what axis? X. So like I said before, sometimes things will get mixed up, but for the most part, they try to stay the same. In this situation, because they put time at the bottom, that's our X value, they did flip-flop our table. So instead of it being an X over Y, it's a Y over X for the table, but that's okay. We're fine with that because we know that time is always going to be our measurement for X in this situation. And the speed, your distance, your speed, the rate that you're moving at, that's going to be your Y. So I'm going to go ahead and put those labels next to it so that I understand. When I am checking for the change of my Y, I'm going from 0 to 9.8. That is an increase of 9.8. And that happens to be the same throughout the entirety of the chart. When I go from 9.8 to 19.6, it is 9.8 for the change. Then when I go to 29.4, that's an increase of 9.8 as well. When I go from 29.4 to 39.2, it's an increase of 9.8, and it just keeps going. So that means my change of my Y is going to be 9.8. That's my change. Okay, now for the rest of my constant rate of change, I need to make sure that I identify what my change of my X is going to be. Okay, so for here, that's really simple. I'm going up each time by a value of 1. So it's a positive 1 for the change of my X. Okay, so that does make it a linear relationship, so we're good with that part. Straight line, checks off. So now we need to identify if it starts at the origin. So if we're looking at our table, does our table have the point 0, 0 on it? Yes, so it does happen to start at the origin as well. So the fact that it is linear and it starts at the origin does make it a proportional relationship. I do apologize for future reference. I usually would have the labels on the bottom for the tables, but I forgot to put that on there for you guys. I do apologize. But for your x-axis, which is going to represent your time, what I want you to do is I want you to go ahead and skip every other line. So obviously the corner piece is going to represent a 0. Then you're going to skip a line and you're going to label it 1, skip a line, label it 2, skip the line, go to 3, skip, go to 4, and so on and so forth. That just helps us to see a little bit more definition with the line. Now for my speed, I know that I need to get all the way up to where 49 is at least. So that means that each one of these lines, in order for me to be able to get up to the point 49, it's probably best if I count by 4s. you know, because of how many that I have here. Counting by 5s, that's going to make it a little bit too much. If I count by 3s, then that's not going to be enough. But if I count each of these by 4s, because I think I have, what, 14 lines? If I have 14 lines and I only count by 3s, then that's only going to get me up to 42. I need to get up to the point 49. So I'm going to go ahead and count by 4s. That'll get me all the way up to 56, which is well past my value of 49. That's how I just let you know how to identify what you should count your intervals by. Always identify what your largest point is, and you want to make sure that you're able to get past that. Okay? So we've got 4, 8, 12, 16, 20, and then we're just going to keep going. Again, I do apologize. Normally I would have this up there for you guys. Okay. So if you have them labeled correctly, you should have gotten to the point 56 at the very top. And then we just go about graphing them. Now, obviously, these are some decimal values, so are we going to be very accurate with our graph? Probably not, but these are just going to be basic rough estimates to where it should belong. The one point that is going to be very accurate is that 0, 0. Now, when they were at 1, it was at 9.8, so we're at 1, and 9.8 is going to be roughly almost halfway between that 8 and 12 mark. But again, I'm just going to draw it right halfway, and I'm just going to make my dot a little bit larger so that it kind of makes up for that discrepancy. At 2, it's going to go up to 19.6, which is basically almost the 20, so I'm going to hit it right at the 20 mark, maybe slightly below. For 3, it's going to go up to 29.4, which again, it's slightly closer to the 28 line. For 39, that means it's going to be kind of close to that 40 mark. And the 549, we're going to go all the way up to where, just slightly above the 48. And that's just our basic estimate of what it should look like. Strongly encourage you guys to invest in a ruler, because you're going to be needing that a lot when you're trying to create your straight edges. Especially for today's activity, you're going to need a straight edge. So if you don't have a ruler, you're going to want to make sure you get one, because if you're trying to connect your dots freestyle, it's going to look sloppy. And accuracy is key. Okay? That's what it would look like. So again, graphically speaking, it's really easy to identify if a relationship is linear and if it's proportional, because as a graph, it will be straight, it will cross through the origin. The ones that are going to be a little bit more difficult are the ones in which you are having to identify your constant rate of change from a table, and then identifying whether an origin could exist on that table. Okay, go ahead and turn it on over to the back. What I want you guys to do now on the back page is you are going to go ahead and identify a constant rate of change if one exists, so that you can identify if it's linear or not. And then you're going to graph your relationship and see if it would be proportional by seeing if that line can extend to the 0, 0 mark. You're going to do that for both problem, the top problem and the bottom problem. So let's take a look here. For the first point that we need to identify is, does it have a linear relationship? Is this going to create a linear relationship? Yes or no? Yes, it is going to create a linear relationship. What's the constant rate of change going to be? 16, right? 16 over 1, okay? So that basically means that it's like 16. So if we're talking about test scores versus hours studying, okay, this would be your Y. Then that's like 16% increase of your score per hour that you were studying is basically how that would relate. Okay, so we know that as our X is increasing each hour, our test score, our y, is increasing by 16 each time. Okay, so we do know that our constant rate of change, we do have a constant rate of change. That's going to be 16 over the 1. Okay, so that does make it a 16, which does make it a linear relationship. Okay, it is going to be a straight line. Now to identify whether or not it's going to be proportional. So again, to be proportional, it has to be straight, but it also has to go through the origin. Is it going to be able to go through the origin and continue straight? Yes or no? No, right? Because if we decrease by 1 more hour, let's work backwards. In order for me to get to 0, I would have to take away 1, wouldn't I? To get from 1 to 0. So what would I have to take away from 15 to get to move backwards? If I'm moving backwards by 1 for the x, what would I have to move backwards by for the y? Minus 16. So if I'm working in the reverse and subtract 16, that's going to take me to 36. That is not the origin. That is not 0, 0. Okay, so it's not going to be a proportional relationship. It is going to be linear, but not proportional. Okay, so if we're looking at it, at 1 hour, we would be at 52, which is directly in between the 48 and the 56. If we're at 2 hours, we're at 68. That's directly in between the 72 and the 64. At 3 hours, we're at 84. Directly in between the 80 and the 88. And then at 4 hours, we're at 100, which is directly in between the 96 and the 104. Okay, again, if we were to connect that, it should connect down to where 036 is going to be. Okay, and which it does. It connects down, goes straight here to 0, and where 36 would actually be. So it is not going to be a proportional relationship. So I do want to make note, it is linear. Okay, so it does check off on the fact that it is linear. That's one of the requirements for proportionality. But it does not pass through the origin. Okay, so that makes it non-proportional. That makes it non-proportional. What about for the second problem? When we're looking at the second problem and we're comparing weight in pounds, which is our x, I identified that as my x for you guys, and we're comparing mass as the y, is that going to be a linear relationship, a straight path? Is that going to have a constant rate of change? Yes or no? Yes. Let's take a look. If we take a look at the mass, what is our mass increasing by here? By 9. What about from the 18 to the 27? That increases by 9. 27 to 36, that also increases by 9. If we're looking at our x is increasing by 20 every single time. So our constant rate of change, it does have a constant rate of change. Our constant rate of change is the positive 9 over the positive 20. Okay? That's as simplified as it's going to get, 9 over 20. But it does make it a linear relationship. So that's at least one thing that checks off. We do know it is going to be linear. Now we need to know whether or not it's going to be able to go to the origin. So let's work backwards. Instead of adding 9, I'm going to subtract 9. And that would bring me to a 0. Instead of adding 20, I'm going to subtract 20. Go backwards. And that would bring me to a 0. So am I going to be able to go through the origin? Yes, that is the origin. So that means it's going to be a proportional relationship. If I were to graph it, if I decide, hey, I don't really want to work backwards, I just want to graph the points and see if it works out that way, that's fine too. At 20, I would go up to 9. At 40, I would go up to 18. At 60, I'm going to go to the 27. And then at 80, I'm going to go up to where the 36 is. Okay, so I've graphed my points. If I connect them together, again, another important reason as to why you need a straight tool, a ruler, it will connect to the origin for you if you extend your graph. Okay, so it is a linear relationship. Check. And it passes through the origin. So that's another check. We got 2 checks. That means it's a proportional relationship. Now, guys, there are times when you might have a graph that goes through the origin, but it's not linear. If it goes through the origin and it's not linear, is it proportional? No. It must meet both criteria. It must go through the origin and it must be straight in order for you to be able to have a proportional relationship. Okay, so you do have, like I said, you have an activity. It's on paper, but it's also on computer. I have paper copies so that you can work the problems out, but your final turn-in is going to be on the computer.